Hello, this is my project. You'll notice that I'm not using a CPU. My computer does not have an NVIDIA video card, so I have an AMD video card, and TensorFlow was not built for that, and I couldn't configure my computer a workaround. Um, so the very first thing I did for this project was start by researching the OpenCV documentation, the TensorFlow documentation, and the Keras documentation. And then I also researched the legendary 1998 LinNet paper, which was the original feed-forward convolutional network that was able to solve a handwriting recognition. So then I started setting up my model, to create my model. So I loosely, I mean the LinNet structure, I kind of loosely based mine off of that, but it's significantly different. So what I did, I have three convolutional networks with only one pooling after the third convolutional network, and their increasing filters are increasing in size from 2 by 2 to 4 by 4 to 8 by 8. I did this because I thought I can get the most granular features first, and then get some structures like edges and curves, and then after that to be able to get more structures and relations and patterns. So after my max pooling, I flattened it, and then I sent it into a 64 layer dense layer. With all of these are using the Rulu activation, which is a standard operation. And then after my dense layer, I sent it through a batch normalization layer to because I did this because I was having problems with the accuracy, and I did some reading, and they talk about how during stochastic gradient descent, some weights will become much larger and throw off your results. So the batch normalization layer normalizes everything, but to be between 0 and 1. My dropout layer was 50%, and then I sent it to an output layer of 143. So with the activation softmax, and it seems to be working pretty well. I did change the compiler options around to figure out which was really best that worked for me, and the optimizer is in Atom, and I then the loss is categorical cross entropy, and the metrics is categorical accuracy. So yeah, this was pretty successfully working with that architecture for me. Yeah, I did lots of trial and error and to figure out what the settings should be and what the configurations. I played with having more pooling, and that didn't work, and I changed the dense layer values around from 64 to 128, and that didn't work, so I went back to 64. And so I really think I've gotten a smooth, a very smooth increase for each epoch, starting out very low and increasing slowly to a high 90s final accuracy. So that seems to work the best for me, and think this was a very good project. I spent several weeks on work trying to figure this out and reading lots of materials, and it was a great project, and I'm happy that I was able to complete this project. So thank you very much, and you can see my final test accuracy is 98.75.